Ready to go? Ladies and gentlemen, thank you and welcome to another edition of THAT.live. We are here on a glorious Monday morning, and we're going to talk about some security, which means it's a highly confidential conversation that none of us are going to understand. My name is Clark Sell, and with me today I got Micah Silverman, and let's pull him in. Micah, how are you?
Good, man. It's good to see you live, if not in person.
It is good to see you live. It's a different kind of live. It's not as we're socially distanced.
Yes.
In a very long way. All right. So before we get started on this conversation, I'm going to start with just sending you a bit of gratitude, acknowledge you for a minute, because you've saved my ass a few times. I think it's fantastic. The fact that you and there's a number of you guys at Okta who have are out in the community and trying to teach others what to do in this world of security that we are. It is ever changing. It is complicated. You've made yourself more than available to me, a number of times to ask what can only be the most pointless of stupid questions. And I just want to, thank you for that, and thank you on behalf of others, because it's not it's certainly not an easy space. So to be able to, to be out there, to be that, that hug, if you will, for the folks that are down there trying to figure this shit out without really knowing, I appreciate it. So thank you for that.
Oh, thanks, man. Yeah, that warms my heart. That's a big part of what I and the rest of the team try to do. So good to see that we're doing it.
Yeah, I know it's the kind of intangible side of things where, that might not contribute to in that particular example, it certainly contributed to sales, but, there's one thing to buy a product. There's a whole nother thing to use it right and do it. And that takes a lot from both parties. So, again, thank you for that. And thank you for the help over the years. Now that that's out of the way, why don't you, quick introduction, who is Micah?
Yeah, well, thanks. So I am the old man on campus. I like to say get off my lawn a lot. But yeah, I've been at this a long time, man. I graduated college in 1990, so there's that. And that was really like right at the beginning, the pre-dawn of the internet. So my college had a Spark station that was connected to the ARPANET and playing with NCSA Mosaic and the CERN HTTP server. And I had this professor that, in 1991 was like, this is going to be the next thing. You should learn this. And I had graduated at that point. So I was like, all right, I guess I'll learn that. So that's been the story ever since. In 1995, I got to launch Sci-Fi Channel's first website. Security's been in the mix all along, so kind of a polyglot developer before we really had that term. And, C was the original big language for me. And then in 95, Java was released, and I was kind of like, this looked pretty interesting, and been using Java ever since, along with JavaScript. Don't hold it against me. I know there's a lot of .NET people out there. I love all my .NET folks. But just never bothered to learn it because there was so much to learn with everything. You got to have some kind of focus, right?
That's right.
And I've been doing formal developer relations since about 2014.
That's a long stretch.
Yeah. Yeah, I got to co-author a book on Java Enterprise Java Beans, just in time for that technology to be irrelevant. So that was kind of cool.
So what got you into security? Because that's its own set of focus.
Yeah, man, I was fortunate. Doubly fortunate that I didn't end up in jail. But in the early 80s, I was part of this phreaker community, and you may have heard of things like the Captain Crunch whistle and 2600 and back then you could own the phone service if you knew the right frequencies. It was all about analog audio frequencies, and me and my friends got involved in all of that. And then things naturally progressed and started tightening up, and everything became digital. And you know, I had a kind of a bad attitude from the beginning. Like if somebody said you're not allowed in here, or you're not supposed to be here, or this isn't for you, I would try to find a way in. So, fortunately, I became much more of a gray hat before I got into any real trouble. But my title now at Okta is Senior Security Hacker. So I just like to find APIs and beat up on them, and see what I can see and see what I can do in interesting ways.
Now, you put out, before this conversation, you put out kind of a I don't want to say a request for input or validation as to what people kind of wanted to hear, and it looked like it was overwhelmingly around OAuth. So let's just start with the world of OAuth. For those who may not know, can you give a quick, what the hell is OAuth? Why should I care?
Yeah. I'd be happy to. And actually, in just a moment, I'll show like a little survey. I'm curious to know people's level of comfort and experience with OAuth, and that may drive the directions that the conversation takes. But
For sure.
basically, OAuth addresses this question that was on everybody's mind around 2007 of how do I let an app access my data without giving it my password? Because up until that point, sites like Facebook and Yelp and others, when they wanted to read your contacts so that you could connect with your friends, they'd have you put in your email address and password for an email service like Gmail. So you'd go to Yelp, but you'd put in your Gmail username and password. Yelp promised up and down they wouldn't save your password, they wouldn't do anything bad with your data, right? And maybe Yelp did, or maybe they didn't, but lots of other companies did, and we had breaches and all kinds of problems with plain text passwords. And really what we were trying to express back then was I want to give very limited access to Yelp. I want them to have read-only access to my contacts, and that's it. But once we gave them our username and password, then they could masquerade as us essentially and send emails as us, write to our contacts, go and scan our Google Docs. I didn't want Yelp to have all that authority. So I wanted, so the question that ultimately turned into OAuth is, how can I let an app access my data without giving it my password? And that's a shorthand for how can I let an app access my data without giving it my password, and also have that app have very limited access to my data, and also be able to revoke it, have that revocation under my control. Because once I give them my password, the best I can do is change my password, which is not only a hassle, it might affect other services.
Right.
So what emerged out of that conversation was what we now know as OAuth.
And, this is, it's so like pivotal to everything that's going on today. I mean, dare I say, how much does one really have to know about OAuth to be secure? Like, you're a small company of 5. Like, do you need to be kind of all in, like super vested in this? Or is there enough other people and frameworks out there that we can get pretty close?
Well, the answer may be a little unsatisfying. There's a guy out there, David Allen, who wrote the book Getting Things Done, and he talks about the number of inputs into your system. How many inboxes should you have? And the unsatisfying answer is always like as many as you need and no more than that. And it's kind of similar with OAuth. Like, you need to know a certain level to make sure that you're using OAuth right, but you really don't need to like be wading into the maze of the spec and all the other specifications that it builds on. And the good news is that my colleague Aaron Parecki works on the OAuth specification, and he's one of the primary authors of the next version of OAuth, which is OAuth 2.1. We're on 2.0 right now, and 2.1 is the whole purpose of 2.1 is to slim down the OAuth spec. And really it comes down to 2 or 3 flows that are valid. Right now there's like 5 of them and they get misused, and some of them are deprecated because there's security problems, but they're still part of the spec. So providers like Okta still support those outdated flows. So there is understandably some confusion around OAuth. If you're using a library, which first of all you should be, regardless of whatever OAuth service provider you're using, even if you're using an open source provider and hosting it yourself like Keycloak, you shouldn't be like building your own service from scratch. We should start there, and you should be using a library. There's lots of good general purpose and specific .NET and Java and Node.js libraries. There's no reason not to be. So, I know the world of Java. If you're using Okta's Spring Boot integration, it, you set like 3 configuration parameters, and then you're kind of done. And it's using the right flows, and it's, connecting it to Spring Security in such a way that if you know Spring Security, you just use Spring Security as normal. Behind the scenes, it's getting tokens and redirecting you and parsing those tokens and doing all that stuff. But you shouldn't have to be that concerned about it. And while we're on Java, the good news is that Spring Security itself supports OAuth generally. So if you're not using Okta, you could still use a Spring Security library and integrate with OAuth just fine. So, standards are great, libraries are great. I kind of live and breathe this stuff, so I like to understand the inner mechanics of it. But if you're a developer wanting to do the right thing, an hour-long video or a session or like a 3-part blog post or something like that, or even a normal blog post on OAuth should be enough to give you enough foundation to then make sure that you have it configured right and you're ready to go.
Where do you see people screwing up the most? Like, where do you, if hindsight being 2020, where do people misstep the most?
I mean, part of it is through no fault of their own, and part of it is, through their own fault. So the most common misstep, I would say, and the one easiest to avoid, is rolling your own. It's kind of like, people, especially non-developers, but developers too, sometimes wade into something and it's like, oh, calendars, that should be easy. But then you get into like time zones and, it's like a big thing. So people kind of have that attitude with security, like, well, this isn't the focus of my program. I just need username, password. I'm going to blow this out and then I can focus on the business logic. And we kind of say on the developer advocacy team, we say that's right. Security isn't the main focus of the application you're building. So offload that to a service that's all we do, and then focus on the business logic of your application. The part that's not developers' fault is, OAuth 2.0 has been around since 2012, I think, the latest official version of it. So, 8 years is a long time in computing years, and there are aspects of it that have gone stale. And while they're working on new versions, they release these security best practices documents. Those are other formal specification documents that people usually aren't going to take the time to wade into, but it makes it understandably confusing. And so if you just follow some even recent or off-the-shelf examples, you may end up doing things not according to the best practice because, that's the example that you were given.
Yeah, and I know we kind of laid out a few things to talk about, before this call, and one centering around OAuth flows, and even the conversation you and I had, I don't know, many months ago was, around Pixie and doing that. Let's dive a little bit into that, because I feel like you guided us down this path where could have gone south. I shouldn't say could have gone south. Could have misstepped pretty hard when it didn't need to be. Can you talk about some of those flows and why things like Pixie are important, and kind of steer the boat straight?
Yeah. If it's okay, I'll share my screen here. Can you see my
Your
screen now?
your screen is shared.
Sweet. And
Sweet. And if it's okay, I'm just curious
if people would jump
people
in
would jump
here.
in here.
It might help to kind of level set the conversation. So if you go to
Slido.com,
you just put in the five letters Micah. That's my first name. And then this little poll should be live. And choose one of these 5 options. Where are you at with OAuth? And if we get 5 or 10 or more people answering here, we might be able to kind of level set. And if nobody answers, then I'll just start from the start.
Yeah, I just put it out in the chat.
Cool. Yeah, give people
a little bit. Everybody a moment.
Mm-hmm.
I'll even answer it myself.
Nice. Yeah, we got a few coming in. Awesome. Hopefully a couple more. Don't be shy, y'all.
I see you hanging out in chat. Let's go.
All right, we got a total flow wrangler in there. Nice.
So while people are answering that, let's is a good place to start with what the flows mean?
Yeah,
like
sure.
What a flow is?
Yeah, that's a great place to start. In the world of OAuth, or let's just say prior to the world of OAuth, there were kind of 3 actors. There was you, the user. There was the service you were using, like say Yelp. We can call that the application. And then there was a service provider like Gmail that had your contacts. And that was kind of it. And we would put our passwords in, and then Yelp would go and read all our passwords. So it was really after we put our password in, we were kind of out of the picture, and it was really just Yelp interacting with Google. With OAuth, there's a couple more actors that perform a little dance to make Yelp, in our example, able to access your contacts in a controlled way. And that little dance is what we call a flow. And the whole goal of any of the 5 current flows, 3 that are really still relevant, the whole point is for a client like Yelp to get an access token. That access token enables Yelp to interact with an API like the Google Contacts API. So now there's you sitting in front of your browser, there's Yelp, there's the Google Authorization server. That's like where you go to authenticate. That's accounts.google.com. And then the Contacts API. So there's like these 4 actors, and they all kind of dance with each other so that Yelp can get an access token and read your contacts on your behalf. So that's the goal of any of the flows. And then the whole reason we have these different flows are for different contexts. And I have, let me just see, I have a slide I can share on that. Bear with me a sec. I'm gonna jump around a couple of different slide decks as we go here. But this slide kind of goes over the different flows and the context that they're meant for. And if you notice at the bottom, there are these 2 flows, the implicit flow and the password flow, that while they're still officially part of OAuth 2.0, they've been deprecated through the best current practice security documents and shouldn't be used anymore. That's the punchline. Now, there's a lot of implicit flow going on out there because there was a time when that's the only flow that was available to you for a browser app, for a spa app. But now there are better alternatives, and we want to encourage people to move away from the implicit flow because it has some specific security concerns. But so the good news from like learning OAuth perspective is in most cases, there's only 2 flows that are really going to be relevant to you. In most cases, it's going to be the authorization code flow, possibly with the Pixie extension. We'll talk about that. Or the client credentials flow. The client credentials flow is for when there isn't a user involved, but you still want to take advantage of this OAuth framework so that your microservices can talk to each other securely, server-to-server communication. The device flow is a little more exotic. It's still very valid, but most of the customers we encounter don't really need it. That's for input-constrained devices. You've probably encountered the device flow and you didn't even know it, like on your Apple TV or your Fire TV or your Roku. If you launch the Sci-Fi Channel app, it asks you to log in and it gives you a URL and a code. And then you go off to your mobile device or your laptop and you go to that URL and code. And then on the screen, as if by magic, it transitions on to let you watch full episodes. That's the device flow. And the whole point of that flow is for when you're dealing with input constrained devices, because it's kind of a drag to use a virtual keyboard on your Apple TV and put in your username and what might be a really long password. For most of us that are building apps, it would be the other two.
I have to assume, though, that the device flow is certainly growing as we get more Apple TVs and Rokus and apparently refrigerators with screens. I would assume it becomes mainstream.
Oh, definitely. It used to be relegated only to things like your Apple TVs and your Roku devices. Now it's refrigerators, IoT devices. There's a video encoder that's got like a 3-line OLED screen and 2 buttons. That would be a real nightmare to try and have to manually input a username and password. What's especially exciting to me are the IoT devices that are now coming out that have an OAuth stack and support the device flow, because IoT security has been abysmal. And it was kind of repeating sins of the past where different vendors were doing different things and doing their own thing, and it wasn't secure. And now, I use USAA as my homeowner's insurance company.
Yep.
And they have some devices now where they'll give you a break on your premium if you install like their water sensor, so that it's mutually beneficial, right? If your water heater has a leak, it'll detect it and alert you before there's a lot of damage. And it's great for USAA too, because they won't have to pay out as big a repair bill. But those devices are all OAuth enabled with and they use the device flow. So you go through a quick thing that we've probably all encountered to get the thing on your network. And then, you go to a landing page and it says, go here, put in this code, and now it's on your network and it's connected to USAA in a secure way.
Yeah. Okay, so let's
see where we landed here.
Yes. Yep.
Not there. Too many screens. There we are. Yeah. All right. So it looks like, most of the people that answered have some experience with writing code to integrate with OAuth. So the next thing I wanted to put up here is kind of a choose your own adventure. Hopefully the same 6 people will answer. You touched on Pixie, which is a great topic. But, I've basically accumulated, I'm very tactile the way that I learn and the way that I like to present. So I've kind of accumulated these demos of different aspects and issues of OAuth. And, we may be able to get to more than one of these, but I kind of wanted to see what people would like to see first. So I have a Pixie demo. That's the extension to the OAuth flow that allows you to use the safest and most secure flow in your browser SPA apps, in addition to mobile apps. That's what it was originally created for. I have this auth code injection attack. So the authorization code flow is the most secure flow, but it does have a vulnerability if you're not using Pixie. And I kind of demonstrate this. It's been theoretical for a long time. I didn't do the primary research on this vulnerability, but as far as I know, I wasn't able to find any practical applications of it. So I created a practical application of it where we can see this vulnerability in action. The implicit flow detector is a browser extension. Whether or not we do that demo, it's available on the Chrome and Firefox browser extension stores, and all it does is detect websites that are using the deprecated implicit flow and alert you to that fact so that you can then go alert those sites and say, hey, you shouldn't be doing this anymore. And hopefully if enough people do that, they'll change over because there's no good reason to still be using the implicit flow. So we have kind of 4 choices, and we may be able to get to more than one of them, but looks like maybe we'll start off with OAuth Theater. If anybody else wants to weigh in, and then we can jump into Pixie and the authorization code injection attack.
Well, looks like
all right, cool.
OAuth Theater is the winner.
Yeah, we'll start there, and hopefully we'll have time for some other stuff too. All right, so here is the thing with OAuth Theater. Oh, actually, bear with me a second. I want to go to a greenfield browser here. So if you go to, bear with me a second. I'm just going to start something here. Okay, if you go to OAuth.theater, that is the top level domain. You can join this game. The game is called Pastoral Slope. Don't start a new game. We want to have one game here. This is designed to be able to support multiple games at once. It's something that I'm working on building out to be like a fully contained landing site, but it's not quite there yet. So join Pastoral Slope, and you can join either as a player or as a lurker. Now, if you don't want to be a player, you can just look at my screen, or you can join as a lurker and look at it on your own screen, whatever you want. But if you do join as a player, then you're going to be one of these 4 actors. We have Pat, we have Yelp, we have Google, and we have the Contacts API. Now, I can see that Pat joined, so we need 3 more people to join as players in order to play the game. So now we have Pat and Yelp. And for those people that joined, you should see a little spinny diamond thing over your head. Now, don't run into anybody yet, Pat. You can move around, but don't run into anybody yet, because then that'll kick off the play, but that's fine. So you move with the arrow keys, kind of classic, side-scroller game style. And then the space bar is the action key when we need it. Now, right now, we only have a Pat, so we need 3 more people to join as players. And if need be, I can always take over as the players. That's kind of built in. I can cheat. But when you do join as a player, you'll see this little spinny diamond thing over your head, kind of like Sims style there. But make sure you join Pastoral Slope. So far, we only have a Pat. We had a Yelp for a second, but Yelp left. Oh, we got Yelp back.
No,
good. So Yelp and Pat are moving around. So we just need a Google and a Contacts API.
So for those in chat, hit up OAuth.theater. That's the URL where this game is at. And then select the game. Don't start a new one.
Yeah, select the game Pastoral Slope. That's the name of the game. And for now, for Pat and Yelp that are in there, feel free to move around. Just don't run into anybody else yet, because this game, detects collisions like a lot of our classic games. And I'll just give you some ground rules while we're waiting for other players. And if we don't get other players, I'll just play as the other players. The ground rules are there's always instructions at the bottom of the screen, and it's either going to be a goal or an action. So right now we have this goal. Pat goes to Yelp, but don't do it yet. And then along the way, it may say something like, Pat, press the space bar, or Yelp, press the space bar. The only action key is the space bar. Couple other things, and actually I didn't think about this in advance, so I may have to do some of this myself here, Clark. But there are speech bubbles that are going to appear over the actors, and ordinarily when I'm doing this as a workshop, I'll unmute the people that are the actors so that they can actually say the lines. But I'll say the lines since everybody else is on mute. Maybe you and I can share that responsibility there, Clark.
Yeah. Yeah, we've managed to glue the internet together in weird ways right now.
Yeah, exactly. So why don't I take on the responsibility of being Google and the Contacts API, And then we already have Pat. Are you one of the characters here, Clark? Are you Pat or Yelp?
I'm Yelp.
All right, cool. So when Yelp's lines come up, you can say them, Clark,
Okay.
and then I'll say the lines for everybody else. All right. So we always want to look at the bottom of the screen to see what the goal or the action is, and we'll go off there. Now, what we're emulating here in this little game is the authorization code flow. So we're going to get kind of a feel for the mechanics of this flow and how it works. All right. So first goal is Pat goes to Yelp. Pat, go and run yourself into Yelp. Oh, we got a Google now. Awesome. So I'll just be contacts. All right, Yelp, your line. Whoop, we pressed it too quick. Now you want to give somebody a chance to say their line. So it's all right. We're just learning here. So so Yelp said, "Hey, would you like me to access your contacts?" And Pat, if you move off of Yelp a little bit, Pat right now is saying, "Yes, I would." All right, now you press the space bar, Yelp. Oh, we got a, yeah, good. So your line there, Clark.
Go to Google to authorize me.
All right, good. And so now, Pat, you have the instruction on the bottom of the screen, and you're telling Pat to go to Google to authorize him. So Clark, move yourself off of Google there. That's all right. Now, by the way, just as an aside, this is an important part of how this whole system works, is that we don't want Pat giving credentials to Yelp. So Yelp is saying, go to Google to authorize me. All right, now, Pat, move off of Google for a sec. Hold on, I'm gonna, yeah, good. And now, Pat, your instruction is to press the space bar, and then I'll read the lines. So Pat, press the space bar. There we go. Okay, and so now run yourself into Google. Good. Now Google says, credentials, please. And now, Pat, you're going to press the space bar. And Pat says, here you go. And now the credentials have moved from Pat over to Google, never touching Yelp. That's good. All right, Google, you're going to press the space bar now. Google says, do you consent to Yelp having read-only access to your contacts? Pat, press the space bar. Yes, I'll allow it. Now, Pat's consent has gone over to Google. Again, never touching Yelp. Now, you've probably seen these consent forms where it says, you know, this app would like to do this. Google says, very well, take this authorization code to Yelp. Now, Pat presses the space bar. Now, Pat is in possession of this authorization code. So pause here for 1 sec, and you may have questions. What is this code thing, and why do we have it? Pat authenticated to Google, gave Google the consent. You can see over here, if you take a look at Google, Google has this access token, and as I said before, that's the whole goal, is to get Yelp an access token. So why doesn't Google just send the access token now? There's a good reason for that, and it's why we have this little dance. But let's see how this plays out. So now the new goal is for Pat to deliver this authorization code to Yelp. So Pat, go ahead and run yourself into Yelp. All right, Pat said, here's the code from Google.
All right.
Yelp, this is your line.
Thanks. Time to get the access token.
So Pat handed the code to Yelp, and now Yelp is going to go to Google.
I have an authorization code I'd like to exchange for an access token.
Now Google says, give me the code and your secret so I know it's really Yelp. So Yelp has a secret, and he's using that secret and the code to send over to Google. Google says that's a good code. Now Google presses the space bar. Who's my Google out there? Press the space bar. Or I can always override it. I did. And now Google says, here's an access token. And now when Yelp presses a space bar, the access token goes over to Yelp. So that's been the goal all along. Yelp has its hot little hands on an access token, and now Yelp can use that access token to interact with the Contacts API. And at no point did Pat have to give credentials over to Yelp. So you're going to go over to the Contacts API. Go ahead. Oh, we missed a line there.
Oh,
Yelp said, hey, I'd like to.
Hey, I want all my contacts.
Yeah. And now the Contacts API says, I'm going to need to validate this token. So now the Contacts API is going to go over to Google to validate that token. So this is what I mean by the dance. This is why we call this a flow. All of these actors are involved at one point or another. So now the Google Contacts API has been given this access token, and now it's going to go over to Yelp and says, Yelp wants to read Pat's contacts. Is this a good token? Google says that is a good token. And so now the Contacts API goes back to Yelp and says, here's a list of Pat's contacts. Yelp presses the space bar. Last line.
Time to spam all the Pat's contacts.
Right. So a round of applause for everybody. Thanks for participating. But the point here, hopefully, the kind of the goal of this game is to raise more questions than it answers. And throughout that flow, this is what's happening in your browser when you have an application like Yelp that's using the authorization code flow.
So when we first started this flow, you get back an authorization code that, Yelp went back to Google to get the token. How is Google making sure that that is the right, like, didn't get intercepted and somebody else other than Yelp isn't getting that, using that token to get the...
Yeah. Well, that's a perfect question, and it's the reason that we have this authorization code in the mix at all. So what we're emulating here is Pat sitting in front of the browser. And when Pat goes to Google and authenticates, and Google returns this authorization code, that code passes through the browser's address bar. And that's where that's the most vulnerable part of the flow. And it's the answer to the question, well, why don't we just return the access token right away? Because we don't want the access token going through the browser's address bar. Because if the access token gets intercepted, access tokens are what are called bearer tokens. And bearer tokens, like it implies, can be used by whoever is in possession of it. So if the access token gets intercepted, it's kind of game over. That malicious browser extension can go and use that access token to go and read all your contacts. That's not what we want. So instead, Google passes the code through the browser's address bar. Now, the code can be intercepted the same way the access token can be accepted, but the vulnerability there is very limited. If you have a malicious browser extension, for instance, that intercepts the authorization code, the only thing that code can be used for is to exchange for an access token, and the only way to exchange the code for the access token is to have a secret. And there's no way for that malicious browser extension to know what that secret is. Also, the code has a very short time to live. It's 30 seconds if you're using Okta, but it's similar, with other service providers. It'll be some sub-minute amount of time that you have to go and use that code, and it's one-time use. So it has all those protections. And so what we were emulating in the game here, if you remember, the code went from Google to Pat, and then Pat delivered it to Yelp. What we were emulating there is a browser redirect. So when you do a redirect, it passes through the browser's address bar and then goes on its way. The browser automatically follows a 302 redirect, and so the browser passes that code over to Yelp. Yelp has the secret that it pre-established with Google, and so it can exchange the code for the token in a way that my browser, my infected computer, whatever malware I have running on it, really can't do anything with that code at all. Does that make sense?
It does, but I guess the place I'm getting confused is the secret, because I thought the secret was on the application side who wants to do that.
That's right.
Not on Yelp's side.
Well, Yelp is the application in this example.
Okay.
So Yelp is our application where let's say it's a .NET application. We access it through the browser,
Gotcha.
but the application itself is running in their data center behind their firewall.
Right. So
now this leads to a natural kind of good point, which is, well, how do we manage this for spa apps that do run in the browser, where you have JavaScript running in the browser, and that's where Pixie comes in.
Okay, so Mike had asked a question. Does Google and Yelp communicate behind the scenes or back end? So I think we answered that in the sense that this is Pat going to Yelp and wanting to log in with their Google credentials, but Yelp has already established the secret to do that authentication with Google. And so when Pat goes to Yelp and gets redirected to Google to log in and gets the code back, when they present that code to Yelp, Yelp then takes that code and their secret, presents that to Google to get the authorization token that comes back to them, and then they can act on behalf of that user or whatever's been granted.
Yeah. That's exactly right. And what you're describing is what we refer to as the back channel, because when Yelp exchanges the code for an access token with Google, your browser is not involved at all. That's Yelp's .NET application making a post request to Google, and they're both in their own data centers behind their own firewalls, and your browser isn't involved at all. So it's a very secure channel of communication, and it's why this code thing is involved at all, because we want to leave your browser out of it. And really what we mean by that is we want to leave your individual laptop or desktop that we have no control over. We want to leave that out of the equation as much as possible.
So then you get back, and maybe we're going to get there, but the end result of that though, so we have the token, and then that does sit in the browser and is passed back and forth to, is that passed back and forth to Yelp so that you don't have to log in again?
I mean, ideally, the ideal situation for a browser application, a web application that's using OAuth, is that the tokens never make it to your browser. That's the ideal situation. It's not always possible based on the use case or the user experience you want to have. But in this example, if we're talking about Yelp's .NET server sitting in their data center, that access token, sits there maybe as a session parameter or something. And then when the browser needs to communicate, like let's say there is a spa app. Well, if you're using an Angular app, you can just use the session mechanics that are built into Angular and have it connected to your .NET app and never have to send the token down to that Angular app. So let's just say the Angular app wanted to show a list of contacts. Well, it would make a request to Yelp. Yelp would use the access token to go and get your contacts, and then Yelp would just return, say, a JSON response back down to that Angular app with your contacts. Now, that could be subject to interception and malware and all the problems you might have on your computer, but at no time did the access token ever get to that Angular app.
Okay, so separate than that of they are logged in and can act on behalf of a logged in user. So this is a separate token from you being logged in. Is that fair?
Yeah, that's very fair, and it's a great tie-in because around 2012, 2013, 2015, in that time frame, we had a lot of companies, including Facebook was probably the primary perpetrator, was using OAuth in a way that was never intended to be used, and that is for authentication, for single sign-on. OAuth was never meant for that. OAuth is purely an authorization framework. I'm delegating authorization to Yelp to go and read my contacts. That's it. And so what emerged out of that misuse of OAuth, a lot of smart people got together and said, identity is important. Single sign-on is important. OAuth wasn't intended for that. And what emerged out of that is OpenID Connect. And OpenID Connect is a thin layer that rides on top of OAuth and gives us that extra kind of 20% that OAuth is missing that is focused on identity. But okay. OAuth is not intended for that. So, and if concerns of single sign-on and identity and authentication are important to you and the application that you're building, then you'd want to be using OpenID Connect. And the good news there is that anything that you've learned about OAuth is relevant because OpenID Connect does not stand alone. It rides on top of OAuth.
Yeah, and I brought that up because there's it just goes back to all the moving pieces. Like all these things are important and yet kind of dance together. But it's not just one thing. There is this dance of things that have to play together nicely.
Yeah, indeed. And it's a pretty good tie-in. I know we don't have a ton of time left, but it's a pretty good tie-in to Pixie if we want to take a look at that.
I think we should.
Because that kind of that addresses the question. Pixie is an extension to OAuth, and its purpose in life originated for mobile apps. Mobile apps are what we would consider public clients, meaning it's not safe to have a secret on a public client. Even though it's a binary payload for a mobile app, that binary payload can be decompiled and you can extract strings from it. So it's just not safe to store a secret there. And that's the same with a SPA app. For a single page app, for your Angular app, if that app does need to have a token for whatever reason, whether it's a requirement or a user experience or something, in the past, the only way to do that was with the implicit flow, and there's a lot of security problems with that. Now we can use the same Pixie approach because of advancements in the browser and in service providers. We can use that same Pixie Flow. So let me jump to a different slide here, and let's talk a little bit about the Pixie Flow. All right, so this is like a standard sequence diagram. If you're not familiar with them, we have our actors, those are the lanes, and then we see how those actors interact with each other over time from left to right and top to bottom. So the resource owner, that's you sitting in front of the browser. We call you the resource owner because your contacts are a resource that you own and you want to give access to. Client app, in this context, we're thinking about a browser SPA app like the Yelp Angular app. And then the authorization server, that's Google. That's accounts.google.com. And so the authorization code flow is the most secure flow, but it requires this secret, and that's where we run into a problem in SPA apps. What Pixie does is it does a little bit of setup work up front, and then it does a little bit of validation work at the end so that we can have a dynamically generated secret each time we go through the flow and not have to hard code a fixed secret into our application, which would not be safe. So
this is replacing the Yelp has a secret to get to Google. We can't do that because all the code is running, the React app or Svelte or Angular that's running down in their browser and been downloaded. So we don't have the means to securely configure that in, I don't want to say the traditional sense, but like it would be if it was our app on our server.
Yeah, that's exactly right. It's not safe to have a fixed secret in that kind of app. So instead, we're going to use this Pixie extension so that we can manage a dynamic secret.
Gotcha.
So if I jump over to, say, the Yelp Angular app, the first thing that Yelp Angular app does is it creates this random value, which we call V, and then it takes a hash of that value. So there's two things that the app is doing up front that it didn't have to do with the normal authorization code flow. It's creating a random value and it's hashing it. It then redirects over to Google with that hashed value. So this is passing through the browser's address bar, but it's the same sort of hashing algorithm that modern identity providers like Okta and others use for passwords. And the whole point of those one-way hashing algorithms is that they can't practically be reversed with today's computing power. So even if that hashed value is intercepted, there's no practical way to get the original random value V that it was derived from. So now the authorization server has this hashed value and it stores it for later. At this point, the normal authorization flow happens where you identify yourself to the provider. Like in the case of Google, I would submit my credentials, and it may be a little hard to see because of the contrast, but those credentials are completely bypassing this Angular app. They're going right to Google. So I'm authenticating with Google. I'm giving my consent, just like we've seen in other applications. This is all kind of normal authorization code flow. And now Google redirects back with this authorization code that in this diagram I call alpha. So that authorization code also passes through your browser's address bar because of the way redirects work. And it's possible, or as security professionals, we assume that that authorization code has been intercepted. But here's where it gets foiled, and that is in the exchange step. The exchange, rather than the fixed secret, it now passes along the dynamic secret V, which your malicious browser extension, the malware on your computer, the viruses couldn't have access to, because it was the application itself that created that random value. So this dynamic random value V that is different every time we go through this flow stands in for the fixed secret. And the way that Google now validates that is very similar to what we do with passwords. It takes the hash of that random value V and it compares it to the hash that it stored earlier in the flow. And assuming they match, and assuming the authorization code is good, now it will return an access token to the Angular app. That happens as a post. So steps 8 and 9 here happen as a post. So that does not pass through your browser's address bar. And, depending on how infected your computer is, it could still be intercepted, but it's harder to do so with this type of interaction.
Yeah, so so let me try to regurgitate this, because I think this was
sure
a few aha moments for me with I guess React and the worlds that we live in today.
Good. And just as an aside, after you work your way through it, I have a demo of this in action that we can show maybe as kind of the last thing.
Yeah,
go ahead.
So I think most of the people who have been listening have in some way have already done this. So when we redid that conference.com, it's a React app. Now it does play in server-side land, so there's some complexities there. But when you go to log in, we redirect you to, in our case, Auth0. So we have a dedicated login page, which is not controlled by us by any stretch. So that's us redirecting. That's your step 3, redirecting to the authorization server, which happens to be our domain that.tech. And then it returns, eventually you'll get that code back, at which point our app then goes back to Auth0 and gets the token and then keeps it for that session. So you've hit the login button, you've been redirected kind of away from us, but yet tied, handcuffed to us. And then we interact back and get the tokens back, and it runs with the session. So we're completely out of the loop for that whole middle exchange, other than having the secrets to say, go validate, and being locked down on DNS and domain names and that kind of stuff.
Right.
Jumbled, but I think that was mostly correct.
No, and that what you're describing is the greatest way, the most secure way to have that separation of concerns. And there are a lot of customers that we encounter that resist redirecting, usually for user experience purposes. Like, we wrote this, beautiful single page app. Why do you want to do a full page redirect? The reason is, and I can tell you, as having developed applications on the side, as a developer of applications, I don't want to handle your credentials. I don't want to know anything about your credentials. That's not what my app is focused on. So you redirect over to the entity that's their job, like Auth0 in your case. And it's become a lot more civilized because of the fact that you can have custom domains with these redirects. That wasn't always the case, and that made customers more resistant, understandably so. But now you might have, that.tech, and maybe you have login.that.tech. It's all in the same world of the same domain. And so from a user experience perspective, there's nothing that alarms your users or gets them off balance. But now you have this great separation of concerns where the credentials are going where they're supposed to go, your app can do what it's supposed to do, and you don't ever have to worry about handling credentials.
Yep. Yeah, it was you sent us down that path. That was a big kind of aha moment of getting out of the business of any of that security stuff. I mean, we torched our old system. We torched every bit of it, and and we're not in that business. Now we just link an ID to a profile to be able to display pictures and names, but that's
sure,
minuscule.
Yeah. I don't know about you, but as a developer, deleting code is almost as satisfying as writing code.
Oh, so for sure.
That's good.
Yeah. and it is an exchange. Like there's a lot that kind of happens there to get it all to sync up. And I think the thing that has become a challenge for us playing in this open source world is how do we effectively let people do development on our UI or at the app servers, because now you do have to have a secret, which means you have to have a different tenant, because I can't give you the production secret because now I've leaked I've leaked a secret, right? And so now to do development broader, we have to have separate tenants and environments to do that, which are is the right thing to do, but it also is just more moving pieces, more complexity, more documentation, but it's the right stuff.
Well, I'm not as familiar with Auth0, gasp, I know, but I believe that it's similar to Okta in that you can have any number on a single Okta org, which is what we would refer to as a tenant, and we kind of reuse these words, so it may be different with Auth0, but with the same Okta tenant, you can have any number of applications, each with their own secret, but still using the same pool of users. So you could create a separate application that does its own thing, that doesn't have access to, the primary application. Maybe that application is limited to a certain group of users, like maybe it's all admins or something, but it has its own secret and it could have its own application, but it's the same, behind the scenes, it's the same universal pool of users that you're segmenting in whatever way makes sense.
Right, for sure. And since, as you know, I've been in both of them, you still have to protect your production app as its production. So if you're opening up, in TC's case, since we do open source development, we can't give anybody those production app keys. We would need to have a separate one that's limited to the people who are just doing that development side stuff.
Yeah, that makes sense. So if we have the time for it, I could show a quick example of Pixie in action.
Yeah, for sure.
If we don't, that's cool too.
No, for sure. Let's go. You're going to need to if you're going to show your terminal, bump the size up a bit.
Yeah, sure. And one thing I will say, and I'll come back to this, is at the end here, so I have this slide with a QR code on it, and that leads to a GitHub repo that has references to everything that we talked about, including this Pixie CLI, which is just, Pixie command line interface. So this is emulating like a native application. It happens to be written in Node.js, but Pixie is good for native, SPA, mobile, even backend applications. But this is emulating like a native app. And all I have to give it is an Okta org and a client ID. Because, as I just said, you can have any number of applications with a single Okta org. You need to identify that application, and that's what the client ID does for us. Oops, hold on. Demo monster. I had another application running on the same port. All right, there we go. So the first thing that Pixie CLI does, and your native app, regardless whatever it was written in, would do, is it creates this random value V, which in Pixie terms formally is referred to as the code verifier. And then it takes a SHA-256 hash of this string. That returns a binary value, and we base64 URL encode that value so that it's suitable to pass through a browser's URL bar. So the code challenge is the hashed and base64 URL encoded version of the code verifier. Then it constructs this request. This is the authorization URL, and everything up to here is just standard authorization code flow stuff. We didn't talk about a lot of these query string parameters, so you'll have to take my word for it. But if you were just using the regular old authorization code flow, you'd see all these query parameters. But it adds these two additional ones called the code challenge method and the code challenge. The code challenge is this value. The method just identifies the hashing algorithm that was used so that the provider, in this case Okta, knows the right hashing algorithm to use to check later on. So now when I press the any key, it's going to go to the wrong screen. Let's see. Bear with me a sec here. I have no idea where it launched that browser, so we're gonna try one more time. That's what I was looking for. Okay, so now I have to authenticate, and again, this is like the most vanilla screen. This could be skinned and customized in a way that made sense for your application. So I authenticated Okta. My native app is never seeing these credentials, which is good. And once I do that, it redirects with this authorization code, and that is passing through the browser's address bar, but it requires a secret to be exchanged for an access token. And we can see here that the native app has gotten that authorization code, and now I have 30 seconds to use it, so I have to not talk so much. But what it's going to do is it's going to send that authorization code over to the token endpoint, along with a few other things, but most importantly, the code verifier. That's the original dynamically generated random string that we created. And the part that we're not going to see is that behind the scenes, Okta took this code verifier and hashed it, and then compared it to the code challenge that it had stored earlier. Since that all checked out, Okta now returned an access token, and now the last thing this application does is it uses that access token to hit a protected endpoint. The user info endpoint requires an access token, and it returns a response so that we can see that this access token was valid. So that whole process that we just saw was I lost my presentation somewhere. That whole process that we saw was that sequence diagram that we had just gone through, which is right here, right? So that whole process, I even used the same values. So we saw V, we saw the $, we saw the authorization code, and how the whole flow worked.
Yeah, and I know I was talking about Auth0 before, but we used Okta at the previous client. And not only have I learned a lot from your documentation, because it's fantastic relative to pretty much anything in a security space, but your libraries take a lot of that work. They do it for you, and it's very easy to work with. So, a lot of what you talked about there, I didn't really see much. It wasn't a big deal to use it and to call in your stuff and to create your JWTs and pass them across and validate that the things haven't expired, and they're good. So well done.
Yeah, sweet. And if I could, just a quick shameless plug. If you're already using the Okta Auth.js library for your React or your Angular or your Vue.js apps, we really wanted to make it easy to switch from the implicit flow to the Pixie Flow. And the one thing you'll have to do is change a configuration parameter. You'll have to update to the latest library, but if you change a configuration parameter, it's called the response type. Usually that response type would be token. If you change that to code, then the library will automatically switch over to the Pixie Flow and do all that heavy lifting for you. So you shouldn't actually have to change any lines of code. It should just be a configuration change. And then that should switch you from the implicit flow to the Pixie Flow just like that.
Nice. Nice. Well,
yes, sir.
I mean, without question, there is a ton of stuff. I mean, security is not an easy thing by any stretch. I think services like Okta and Auth0 and even the fact that Google and Facebook and all of them have opened up to, be a provider makes us collectively a lot better. And it's, like you said, this is not, my apps they're not focused on security. This is not a place that I want to be an expert by any stretch. So I guess just thank you, because God bless. It's too damn hard.
Yeah. I mean, we say friends don't let friends build off. And no offense, you're going to do it wrong. But, so that's all we do. That's all that Auth0 does, or any of the other providers. And so I find it personally, having written some terrible auth apps before, I find it a relief to have a standard and to have a service that I can rely on for that stuff.
For sure. We're running over, but with that being said, any parting thoughts?
Well, I'm glad that I just want to thank you and that conference. And I'm just glad that, in the weird time that we're in, that we have an outlet like this to keep our tools sharp and to interact with each other. And, I love the Slack, that Slack channel has been a staple for me for, a couple of years now, that daily and everything that happens there. So thank you for really, having a community for real.
Well, I appreciate that. It is certainly we all make it together, and we are trying to do right, in these crazy times, and adjust and refactor. And, there's not a rule book. So it's the fact that you and I can have this conversation, and I can stream your desktop and video, and we can somehow have a coherent conversation without the internet puking, is amazing to me. So I'm going to put your stuff back up. So if anybody wants to get in contact with you, you've got this nice little slide already up there. Where's the QR code go? I think you said it earlier, but.
That brings you to a GitHub repo that has the slide deck.
Gotcha.
We didn't go through the whole slide deck, but it also it has that slide deck, and it also has links to other GitHub repos like the Pixie CLI project and the implicit flow detector and a bunch of other stuff.
Rock on. Well, that's up there. We'll throw it in the notes, and we'll get this up to the YouTubes and all the places. But with that being said, Micah, I appreciate the time. It was fun to explore this as somebody who's been messing around with this stuff for the last 2 years, to now sort of understand it. Feels a little better, but I'll just say I sort of understand it. So
progress has been made.
Progress has been made. Yep. And I appreciate the answers over the years. So thank you for that. And anybody who's in chat, thanks for spending the time with us today, and we'll get this stuff out. And as always, we're here Monday and Wednesday kicking around. Have a great week. Go secure your shit. Go
secure your shit. That needs to be our new T-shirt.
That's right. SYS. Secure your shit.
Yeah, man.
Yeah, I mean, don't. This is not a place to do it on your own. So, reach out to folks like Micah and seek some help. So, thank you for watching, Micah. Thank you for the time, and we'll see you next time.
All right.